Alright guys, let's go ahead and dive right into it. Alright, so for this lesson, we're doing 2.4.1. So this actually isn't included in the book, but we are covering it. So that's why I titled it 2.4.1. So again, you won't find this in the book. So today we're going to be talking about graphing linear inequalities. So you might have already done some sort of inequalities before in graphing. So this may or may not be a review, but we're going to treat it as if it's not. So before we get too crazy, I have an equation written down, y equals 2x plus 2. So we're going to go ahead and we're just going to graph this equation as it is. So it's in slope-intercept form. So we know that the intercept is at 2 and it has a slope of 2x. And there we go. We have our line just like that. But what if instead of an equal sign we threw in a greater than or equal to sign? What does that mean? What does it do? So in order to answer that question, I'm going to ask you, if we threw in this inequality, how do we know if this inequality is true or not? How do we make sure that it's true? So I'm going to test a point that is both below the line and a point that is above the line, and we're going to see if or not the inequality holds true. So I'm going to start with 0, 0 because that is a very easy point to plug into an equation. So starting with 0, 0, I'm going to use this inequality that we have right here. Y is greater than or equal to 2x. So instead of y, well, I'm putting in 0. It's greater than or equal to 2 times by 0 plus 2. Now that is 0 is greater than or equal to, that's 0, 2. Alright, now let's go ahead and read that inequality. 0 is greater than or equal to 2. Now, does that sound right to you guys? I hope all of you answered no, because that is not correct. 0 is not greater than or equal to 2. So our inequality is false. And if you were to plug in any point below this line, you would get an inequality that is false. Now let's go ahead and try a point above the line. Now if you're going to test any points, I always like to test points that are on the x and y axis, because that way we have a 0 and it's easy to plug a 0 into an equation. So let's just say, let's try plugging in negative 2, 0. So let's try plugging in negative 2, 0. So x as negative 2, y as 0. So our y is still 0, greater than or equal to 2 times by our x value, which is negative 2, plus 2. So 0 is greater than or equal to negative 4 plus 2. 0 is greater than or equal to negative 2. Now let's read that inequality. So we say 0 is greater than negative 2. Well, that is absolutely right. 0 is greater than negative 2. So our inequality holds true. So any point that is above this line right here, our inequality is going to hold true. So what we mean is that this right here, all the points above the line, we call that a solution set. And the points below it are not included in the solution set. But I have one more question. Whether or not the line is included within our solution set. So meaning, are the points that go along this line, will they be included in the solution set? Will they make our inequality true or not? Well, in this case, let's go ahead and say, let's try a point along that line. So right here, 0, 2 is in our solution set. So let's go ahead and plug that in. So 0, 2. So y is going to be 2, and we said greater than or equal to, and then 2 times by x, which is 0, plus 2. Well, 2 is greater than or equal to, that's 0, so we're just left with 2. So is 2 greater than or equal to 2? And yes, because 2 is equal to 2. Go figure. So in this case, yes, we would include the line in our solution set. The line is included. But what if I change this to, I got rid of the equal sign. So is 2 greater than 2? It is not. 2 is not greater than 2. 2 is equal to 2. So if we have something that is not equal to, if our solution, if our equation or inequality does not say equal to, then the line is not included in our solution set. So we have to show that on our line. And to show that, we will dash our line. So draw a dashed line instead of a solid line, all the way along this line. So again, let's go ahead and write that down. If it's greater than or equal to, solid line, and I'm going to say this, that you will shade above. So in this part, in this inequality, we went ahead and we shaded the area, the region that was above the line, because it's greater than, and we tested the point to make sure that was true. But if it's less than, you're going to shade below the line. So if it's less than or equal to, here, one second, I'm not going to include this just yet. So if it's less than or equal to, dashed line. And then if it's greater than or equal to, shade above. If it's less than or equal to, shade below. So for the last step in this portion, shade the portion of the graph that is the solution. So in this case, we will shade above. Alright, so pretty straightforward, pretty easy. Now let's go ahead and try a system with two inequalities and see what that looks like. So let's first go ahead and graph the equations. So let's graph the first equation. Y is less than or equal to negative 5x minus 2. So I'm going to draw this as my orange line. I'm going to draw this as my blue line, just to make sure that I know which one's which. Okay, so let's draw the orange line. So it intersects at negative 2 and has a slope of negative 5 over 2. Right there. That seems pretty good enough for me. Okay, now before we continue, is this line dashed or is it a solid line? So this one, since it's equal to, right there, it's going to stay solid. We're going to keep this as a solid line. So let's go ahead and write that in. Which equations will have a dashed line? Y is less than or equal to negative 5 over 2 x minus 2 solid line. Well, let's go on to our blue line. Y is less than negative 1/2 x plus 2. So right there, that's where our intersection is going to be with negative 1 over 2x slope. So rise is 1 and our run is 2. So it should follow along that right there. Alright, so now my question is it going to be dashed or a solid line? And you can see here that we're going to have a dashed line because it's not equal to. So this line is not included in our solution set. There you go. Now for the first line. So this is for the orange line. Oh, sorry, before we continue, let's go ahead and write that in. So y less than negative 1 over 2x plus 2 dashed line. Okay, so for our first line, will you shade above or will you shade below? So our first line says less than, so our yellow says less than or equal to. So we are going to shade below the orange line. There we go. Okay. Now for the blue line, for the second line, will you shade above or below? Well, it's still less than, so we're going to shade below it. There we go. Now, what we want to realize is whether or not which regions are included. Because you can see that we have 3 different regions. We have this one, which is only covered by the blue line, this line, which is covered by both, this line, which is only covered by the orange line. So this region right here, if we were to plug a point in from this region, it will only work for this line right here, for the blue line. It wouldn't work for this line. And same for this region right here. If we were to use a point from this region, it will only work for the orange line, beneath the orange line, but not beneath the blue line, or above the blue line. So this means that our solution set is only the crossover between the 2 lines. Just like that. So that is our solution. Any point that is within this purple region will keep our system of inequalities true. So that is what a system of inequalities looks like. So we're going to do one more, but in this case we have 3. So I'm going to put this one as purple. I'm going to put this one as orange. And this one is blue, and we're going to follow the same process. We are going to graph the systems of inequalities. So for our first line, we know that it's greater than, so we're going to shade above, and it's not equal to, so it's going to be a dashed line. So, and it crosses at negative 2 right there, and it has a slope of negative 1. But like we said, it's a dashed line. Just like that. Let's go to our blue line now. So we're going to shade below, and it's not equal to. So we're going to have a dashed line. So let's go ahead and add that in. That one's right there at 2 and negative 5x. So down 5 and over 1. That should be good enough. And we said that this one's going to be dashed because it is not equal to. Just like that. Now for our purple line, this one's going to be a solid line because it's less than or equal to, and we're going to shade below. So we're going to go right there at 2, and it's just going to be a regular sloped line. Oops, I did that wrong. Did I? There we go. Just like that. Now, what we really want to find here, notice that the 3 lines that we drew formed a polygon. Now what we want to try and do is find where they intersect, or the vertices of the polygon. They're one and the same. The vertices are the intersection of all the points. And so we already know how to find where lines intersect by using a system of equations. If we use the system of equations, we can see where they intersect. So let's go ahead and do that. Now we're only going to do 2 lines at a time because it will be easier that way. But let's go ahead and take the 2 equations that we have. So let's go ahead and label this as 1, 2, and 3. So let's go ahead and start with 1 and 2. So that's going to be our orange line and our blue line. So what we're looking for, our orange and blue line, we want to find out where that point is. Right. So let's go ahead and write down our equations. I'm not going to write the inequality, I'm going to write the equations. Alright, now I'm going to solve. Now the thing is, what's easiest to do in these type of situations, again, we already have our variables and our constants lined up. So what's easiest to do is just to multiply one of the equations by -1, and that way we can get rid of our y variable and solve for our x. So then this would be -y is equal to x plus 2, and this is y is equal to -5x plus 2. Now we can add these. Now those cancel out, and then we get 0 is equal to, that's going to be -4x plus 4. Okay, and then what we can do is we can subtract 4. Actually, we can add 4x right there. So if we add 4x, then we're going to get 4x is equal to 4, divide by 4, divide by 4, and so x is equal to 1. Now we have to plug that back into one of our equations. So let's do y is equal to -1 minus 2, y is equal to -3. So there we have our point at 1, -3. So that is this point right here at 1, -3. Now you probably could have noticed that just by looking at where it actually is, but that's how you find it, using a method of elimination in a system of equations. So there we go. We have one vertice right there, 1, -3. Okay, now let's go ahead and find this right here. So that's going to be our purple and our orange line. So that's going to be equation 1 and equation 3. So equation 1, where y is equal to -x minus 2 and y is equal to x plus 2. Now here we can just go ahead and add, since the x's will cancel out right there. That's 0. So then we have 2y is equal to, those cancel out, so that's just going to be 0. So we have to divide by 2, divide by 2. 0 divided by 2 is 0. So y is equal to 0. And then we can plug that into one of our equations. Let's say 0 is equal to -x plus 2. Well, we can add x to both sides. So we have x is equal to 2. So when x is 2, y is 0, and that is our intersection right there. Two, 0. Now the last one that we need to find is right here. So our purple and our blue line. And that is going to be 2 and 3. So 2 is y is equal to -5x plus 2. 3 is y is equal to x plus 2. Alright, now again, easiest thing to do is to multiply by -1. So then we get y is equal to -5x plus 2. And then here we have -y is equal to -x minus 2. Now we can add, get rid of the y's, so that's 0 is equal to, well, it's going to be -x, and those are going to cancel out, so that's 0. So if -6x is equal to 0, divide by -6, divide by -6, well, that's just going to be 0. So x is equal to 0. Okay, so now we just have to plug that into one of our equations. Y is equal to -5 times by 0 plus 2. That's 0. So y is equal to 2. So our last vertice is at 0, 2. And that's where this is, at 0, 2. Alright, so now you know how to find vertices of 3 linear equations that form a polygon. And we are going to use that in the next lesson going forward. But to finish this off, we need to make sure that we are shading the appropriate areas. So starting with the orange, we said that it is greater than. So we're going to shade above this line right here. So that's this portion of the graph. Okay. And then for the blue line, we're going to shade below. So that is beneath it. And then for our purple line, we are shading beneath it. That's less than. Now if it's still possible, I hope you guys can still see it. Let's go ahead and use a pretty dark color though. This right here, that is the overlap between all of them. So that triangle region, that is the overlap. That is the solution within that triangle right there. Alright, so that covers 2.4.1. So again, that's not in the book, but there will be a homework assignment. It won't be through Big Ideas. The homework assignment is going to be on Canvas. So make sure you're looking in the right spot for it. Review the video and come to class prepared to ask me questions. Thanks guys, appreciate ya.